Tonight's lesson is lesson 1.5, and it's on solving inequalities in one variable. Now, up until now, we've been solving equations in one variable or equations in two variables, and we're going to move away from equations specifically and move towards inequalities. So to solve inequalities, you would use the properties of inequalities to isolate the variable. So just like with equations, they have the properties of equalities, inequalities have their own properties as well. And we'll go through a couple of those when we go over the examples in the video. The goal of inequalities, just like with equations, is to isolate the variable. So traditionally the variable is the letter x, okay, and we're usually going to try and get that by itself on one side of the inequality sign. Now remember, there are two inequality signs, the main ones, less than and greater than. And then you also have less than or equal to and greater than or equal to. The solution of an inequality is the set of all real numbers that make the inequality true. So unlike our equations, we had one solution, no solution, or infinitely many, we will also have for inequalities no solution, infinitely many solutions, and then we'll have a set of solutions that'll satisfy the inequality. So it won't just be x equals 1, it'll be x less than 1. So this is all numbers less than 1, so that'd be 0, -1, -2, so on and so forth. Some inequalities are true for all real numbers and others have no solution. So again, you can get infinitely many solutions and you can also get no solution, and we'll go over those in the example. The biggest difference, I think, between inequalities and equations is that inequalities also require us to graph the solution set. So that means we're going to take a number line, we're going to draw out our number line, then we're going to draw all of the numbers that represent the inequality. So let's start off with some simple examples. So we have x. The first example is going to be 2x minus 3 is greater than 5. So what we're going to do first is we're going to isolate the 2x. So we're going to get the 2x on its own on the left-hand side. So what I'm going to do is I'm going to add 3 to both sides of the inequality. So I get 2x is greater than 8. And then to isolate the x, I'm going to divide both sides by 2. So I get x greater than 4. So this is my answer. It's all values of x that are greater than 4. And I also get, on my number line, I'll put a 0. 4 is greater than 0, so 1, 2, 3, 4. Okay, and then since it just says less than, it's not less than or equal to, I draw an open circle at 4, and then an arrow pointing the direction of all the numbers. So since it says greater than, my arrow goes towards the left, so this is all numbers greater than 4, so that's 4, 5, 6, 7, 8, 9, and so on. Okay, so both of those are my answers, not just the x greater than 4, but also the graph. Now let's look at the next example, which says x minus 4 is less than or equal to 2. So what we're going to do, again, is we're going to try and isolate the variable and anything attached to it multiplicatively. So that means 2, any number multiplying in front of it, anything dividing it. So I'm going to add 4 to both sides. I have x less than or equal to 6. And then it's just an x. There's no number greater than 1, so it's not 2, -2, -3. So my answer is as it seems. I don't have to divide anything out. And so what I'm going to do from here is I'm going to draw my number line. So I have the number 0, 1, 2, 3, 4, 5, and 6. And then since it's less than or equal to, I draw a closed circle and then on 6, and then I draw an arrow going down past 6. So this is going to be all numbers less than 6 or equal to 6. So that's 6, 5, 4, 3, 2, 1, 0, -1, and so on. So that's why we draw an arrow going towards the left of 6. Now let's look at a little bit more complicated of an inequality. So the other ones we didn't have to do any distribution. This one we do. So it says -3 times the quantity of 2x plus 2 is less than 10. So the first thing I'm going to do is I'm going to distribute the negative 3 to the 2x and to the 2. So this becomes negative 6x minus 6 is less than 10. From here, I want to isolate my variable and anything attached to it through multiplication or division. So I'm going to add 6 to both sides. So I'm left with negative 6x less than 16. From here, I want to get the x by itself, so I'm going to divide both sides by negative 6. Be careful when you do this, because when you divide by a negative in inequalities, you have to flip the sign. So this becomes x greater than negative 16 over 6. Okay, so remember, anytime you multiply by a negative or divide by a negative in inequalities, you have to flip the sign when you do that. So my solution set is all numbers greater than negative 16 over 6, which negative 16 over 6, I can actually reduce this to a smaller fraction, so that's what I'm going to do. I'm going to reduce it by 2, so I get negative 8 over 3. From here, I'm going to draw my solution set on a graph, so I draw my number line. I have negative 8 thirds, and then 0 is greater than negative 8 thirds, so that's going to be somewhere over here. And then I draw my solution set. So I'm going to put an open circle at negative 8 thirds because it's greater than, not greater than or equal to. And then my arrow is going to be everything to the right of that. Let's look at a few more examples. So let's look at this first one, which says 2 times the quantity of 4 minus 2x is greater than 1. We're still going to be graphing every single solution set, so bear with me here. First thing I'm going to do is, just like with that last example, I'm going to distribute the 2 to the 4 and the negative 2x. So here and here. So 2 times 4 is 8. 2 times negative 2 is negative 4x greater than 1. I'm going to subtract 8 from both sides of the inequality, and I get negative 4x is greater than negative 7. And then I'm going to divide both sides by negative 4 to isolate that x, so I get x less than 7/4. And remember, it's less than now because I switched the sign when I divide by a negative. So my solution set is x less than 7/4, and I'm going to draw a graph to represent this. So I have 0 and then 7/4. I'm going to put an open circle at 7/4 because, again, it's just less than, not less than or equal to. And then I'm going to draw an arrow moving to the left of 7/4. Okay, so let's move past these inequalities with one variable on one side, and let's look at inequalities that are a little bit more complicated by adding a second variable of the same type on the other side. So this one, we're going to have 2 x's, not just one, but 2. So it says 2x minus 5 is less than 5x minus 22. Now the way you approach this inequality is what you would approach an equation with 2 variables. So the first thing I'm going to do is I'm going to combine the like terms. So what I'm going to do is I'm going to add 5 to both sides of the inequality. So then I end up with 2x less than 5x minus 17. The second thing I'm going to do is I still have to combine like terms, and that's the x's. So I'm going to subtract 5x from each side. And I get negative 3x less than negative 17. And the last thing I'm going to do, now that I've isolated the negative 3x on one side and everything else on the other, is I'm going to isolate the x further by dividing both sides by negative 3. So I get x greater than 17/3. And remember, again, I'm dividing by a negative, so that's why I flipped my sign. So my solution set is x greater than 17/3. I cannot do anything else to simplify this, so I'm going to draw my inequality from here. So I have 0, 17 over 3, and then I'm going to draw an open circle at 17/3, and then everything that is greater than 17/3 is part of my answer. Let's look at one more. We have 3.5x plus 19 is greater than or equal to 1.5x minus 7. So again, the first thing I'm going to do is I'm going to combine like terms. So I'm going to combine the numbers together. So I'm going to subtract 19 from both sides. I end up with 3.5x is greater than or equal to 1.5x minus 26. From here, I'm still going to combine more like terms, and that's the x's. So I'm going to subtract 1.5x from both sides. So I get 2x is greater than or equal to negative 26. And now I'm going to divide both sides by 2. So x is greater than or equal to negative 13 is my solution set. If you haven't noticed, up until now, I didn't flip the sign. And the reason why I didn't flip the sign is because I didn't multiply or divide by a negative. I added or subtracted. So it's a different thing, okay? So if I multiply and divide, flip the sign. If I don't multiply or divide by a negative, I don't flip the sign. So my solution set is x greater than or equal to negative 13. I draw my inequality on a graph. So I have negative 13 and then 0. I put a closed circle at negative 13. And then I draw an arrow moving towards the right-hand side, because this is all numbers greater than or equal to negative 13. Okay, so for these next two examples, this is part of the homework where you will be asked to find the solution to the inequality, and if it's no solution or infinitely many solutions, you're going to say this. Okay, so this is like the test, right, where not all the answers were no solution or infinitely many, but it is a potential answer. So what we're going to do first in this problem is we're going to distribute, because it says negative 2 times the quantity of 4x minus 2 is less than negative 8x plus 4. So what I'm going to do first is I'm going to distribute the negative 2 to the 4x and to the negative 2 inside the parentheses. So I get negative 8x plus 4, because a negative times a negative is a positive, is less than negative x plus 4. Now, from here, I'm going to combine like terms. So I'm going to subtract 4 from both sides. So I get negative 8x is less than negative 8x. And then I'm going to add 8x to both sides. And I get 0 is less than 0. This is no solution. And the reason why it's no solution is because 0 is equal to 0. It is never less than 0. So you have to watch the sign, because since it says less than here, we only want values that make it less than. But since there's nothing that makes 0 less than 0, because they are the same, there is no solution. Now let's look at the next one. This one says negative 6x minus 5 is less than negative 3 times the quantity of 2x plus 1. So again, the first thing I'm going to do is I'm going to distribute the negative 3 to the 2x and to the 1. So this becomes negative 6x minus 5 is less than negative 6x minus 3. So from here, what I'm going to do is I'm going to combine like terms. So I'm going to add 5 to both sides. And I get negative 6x is less than negative 6x plus 2. Then I'm going to continue to combine like terms and add 6x to both sides. And I get 0 is less than 2, which is always true. Since this is always true, that means that there are infinitely many solutions, or all real numbers. Okay? So now we've seen one where we have no solution, and we've seen one where we have infinitely many solutions. And really the best way to do is just to simplify it all the way down like I did in the examples, and to see, do the numbers you end up with end up making the inequality true? Because again, the whole point of these solutions is to discover, where is this inequality true? The last example we're going to look at is number 26 from the homework set. Okay. It says 2/3 x plus 14 minus 3x is greater than negative 7. So the first thing I'm going to do is I'm going to combine like terms by subtracting the 14 from both sides of the inequality. So I get 2/3 x minus 3x is greater than negative 21. From here, I want to continue to combine like terms. However, I notice right away that I have a 2/3 x and a negative 3x. So I want to combine these two x's together. The problem is that I can't combine a fraction with a whole number. So I rewrite 3 as 3 over 1, and then I get a common denominator. The common denominator is 3, so I'm going to get 2/3 x minus 9/3 x is greater than negative 21. So what I did is I multiplied the numerator and denominator of 3 over 1 by 3. And then now that they have the same denominator, I can combine my fractions. So I have 2/3 minus 9/3, which is negative 7/3. X is greater than negative 21. I'm now going to multiply both sides by 3. And I get negative 7x is greater than negative 63. And then I'm going to divide both sides by negative 7. When I divide by negative 7, I'm going to flip my sign, so I get x less than positive 9. So my solution is all values of x that are less than 9. From here, I draw my graph, so I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I put an open circle at 9. And then I draw the arrow moving to the left because it's all numbers that are less than 9. And that is my solution set. And that is tonight's lesson. So the classwork due on Wednesday at the end of the class period is page 34, numbers 11 through 27 odd, 29 to 32 all, and 33 to 41 odd. Do not forget that you guys have to turn in notes now, okay? So make sure when you turn in this assignment that you also upload the notes you took from this video. And I'll see you all on Wednesday.